Okay, so I'm going to walk you through the written example. Um, this is similar to your week 2 assignment. And so, there are several steps, so I want to walk you through all of them to make sure that the math makes sense. So the problem is that you're going to ship some stuff, right? And you have a shipping container, and you know that the shipping container can have 125 sofas and 0 recliners, or 0 sofas and 275 recliners. And so the question is, well, okay, what are some of the other combinations? Can I maybe have 50 sofas, 100 recliners, those kinds of questions. So we're going to make a inequality. The first thing is let's plot a little graph. Sorry for not being able to make straight lines here with my pen. But let's say you have sofas on the horizontal axis and then recliners on the vertical axis. And if I just sort of guesstimate here, let's just say that this is where 275 recliners would be. And then down here, let's just say that this is 125 sofas. Okay, so as a point, the coordinates of this point would be 0, 275. And then the coordinates of this point would be 125, 0. Because the first value is the x-axis, the second is the y-axis. And so if we draw a line between those 2 points, let me try again, actually. Wow. Okay, third time's the charm. Whoa, there we go. That's probably the best I'm going to be able to do for now. Essentially what you have is any number of sofas and recliners, any combination that lands inside of here is a go. It's a check. Good job. That means that it'll fit. Maybe we should do a smiley face. In here, we're smiling because we can fit them. Out here, we are sad because we can't fit all of them. For example, if I wanted 150 sofas, which would be about here, that wouldn't work. Or if, let's say, you wanted 125 sofas and 275 recliners, that would be right here, also produce sad face because you can't do that. Okay, so the first thing we want to do is come up with the linear inequality. So what we're going to do is we're going to find the slope. Now to find the slope, we're going to use the formula for finding the slope given 2 points, and that's y2 minus y1 over x2 minus x1. And so we're going to use our 2 points. How about if we label these? Let's label, how about x, let's label this one x1, this one would be y1, and the second point x2, y2. Okay. And actually the y2 minus y1, it can be in the opposite order. The important thing is that they are both top and bottom is in the same order, and then these have to be in the same order, x1, y1. But other than that, if you switch it around to y1 minus y2 and x1 minus x2, that also would be, you would end up with the same exact number. So y2 minus y1, I end up with 0 minus 275 over x2 minus x1, which is 125 minus 0. Okay, so you end up with negative 275 divided by positive 125, which is, if I reduce this, I end up with negative 11 over 5. Now, actually, if you look at the written example, it's done the opposite way, but you notice you end up with exactly the same answer, negative 11 over 5. So this is the slope. And notice it's negative and the line is going down, so that matches up. Okay, so good job. We found the slope. Now the second thing is we're going to find the linear inequality. So for that, we'll use the point slope form of the line, and it looks like this. It's y minus y1 equals to m times x minus x1. Now here y1 and x1 can actually be either of the 2 points. So it doesn't really matter which one you use. Either way will lead to the correct result. So I am going to use this one, 0 and 275. And so if I plug that in, I would end up with y minus y1, which is 275, equals to the slope, which I just found is negative 11 over 5, times x minus, and then x1, which is 0. Okay, so let me go down here a little bit. Okay, so what do we end up with here? We have y minus 275 equals to negative 11 over 5 x. So here you would distribute, right? But negative 11 over 5 times 0 is 0. And last but certainly not least, you then add 275 to both sides to end up with your final equation of the line, which is y is equal to negative 11 over 5 x plus 275. Okay, so this is the equation of the line, this pink line that I drew up here. So this line right there, that negative 11 over 5x plus 275, that's the equation of that line. Okay, so now I'm going to write it slightly differently just to make it easier for us to test the points. So I'm going to write it in what's called standard form. Y equals to negative 11 over 5x plus 275. Okay, so the first thing I'm going to do, I'm going to remove all the fractions, because that's really going to help me. So if I multiply both sides by 5, which means I'm going to multiply everything by 5. And I multiply by 5 because the denominator here is 5, so I want to remove that. I end up with 5y equals to negative 11x, because the 5 here cancels with this one, plus 1,375. And then as my last step, I'm going to add 11x, so move the x's and the y's to the left side. So then in the end, I have 11x plus 5y is equal to 1,375. Now, so again, this describes the line. Now, I'm going to turn this into an inequality. And so what I want, again, I want the inequality to describe this happy face area, this area here where it's below the line. So what I want is I want 11x plus 5y to be less than or equal to 1,375. So that's my inequality because I want to be below that line. So this is what I'm going to use to test. 11x plus 5y is less than or equal to 1,375. If this inequality is true, that means I'm here in the happy face area and I can ship that many items. So let's go through and test some. We're going to do several examples here of this, but this is what we're going to be using, this one right here. Okay, so the first example is, can I ship 80 sofas and 200 recliners? Now, if I go back to my picture here, 80 sofas, 200 recliners. Where is that? Well, that's 80 is about here, 200. So you see it, we're pretty close. Visually, it's kind of hard to tell. So we're going to use this inequality here. And so let's make sure that we remember X represented, if we go back to our picture, X represents sofas, right? And then Y represents recliners. So we need to make sure we're plugging it into the right spot. So I have, we have 11 times 80 sofas plus 5 times 200. And the question is that less than or equal to 1,375? And if I multiply and add these, I end up with 1,880. Now, is that true? Well, no, right? This is not true. So that means that I cannot ship that many sofas and recliners. I would have to ship less of one of them, at least. Okay, so let's do a second example. Can I ship, so we decrease the number of sofas. How about 68 sofas and 125 recliners? So we do the same thing. We have 11, but this time 11 times 68 plus 5 times 125. And we ask ourselves the same question. Is that less than 1,375? Well, if we do that work, we end up with 1,373. Wow. That means that it just barely, so that's a yes, but just barely fits, right? So, so that's a good job. Good job. Okay, now the next part, so that those were good examples. The next part is an actual question. And the question is, if we want to, we have that the Burbank Buy More store wants to make an order. And the order will include at most 75 sofas. Now remember, sofas are represented by X. And so we want to know, okay, well, what's the maximum number of recliners that we could deliver in the same container, right? So to do that, notice that the question is how many recliners, right? That's the question. So Y in this case is the unknown. So if I write out the equation, I have 11 times 75 plus 5y, because y is the unknown. Well, I know that that has to be less than or equal to 1,375. Okay, so if I multiply 11 times 75, I get 825 plus 5y is less than or equal to 1,375. If I subtract 825 from both sides, I end up with, let me write it over here, I'm running out of space here, 5y is less than or equal to 550. And then if I divide both sides by 5, I end up with y has to be less than or equal to 110. So that's 110 recliners. So that's how many I could ship if I had to ship 75 sofas. Okay, so I hope this example helps you do your problem, and let me know if you have any questions.